Hello, Matt Davis here with more homework quiz help. This one is from section 8.2. Suppose that from a previous sample, we were 95% confident that the true population proportion was in the interval between 0.0622 and 0.1844. Determine the sample size required in a future study to produce a margin of error of at most 3 percentage points, and enter your answer as a whole number. So first of all, we're going to make some changes to the problem to give help rather than answers. So instead of doing 3 percentage points, we're going to go ahead and work with 3.5 percentage points. Next thing is to figure out the context we're in. So first of all, we're looking at proportions, not means. So we're in proportion land, not mean land. And then they're asking us to determine the sample size required. So we're in the proportion setting and we want a sample size. So in that setting, the formula would be n equals a guess at p, which is what the subscript on the g stands for, is guess, times 1 minus that guess at p, times z star divided by e, with that fraction all in parentheses and then squared. So we need to know a guess at p, z star, and e, and then we can get to work. Well, they've given us an interval where they say we were confident that p was somewhere between 0.0622 and 0.1844. And if you have a guess at p that's a range, you want to guess the number from that range that is closest to 0.5. So in this case, since the entire range is below 0.5, the value that would be closest is the upper boundary, so 0.1844. So that's going to be our guess at p. The E is the margin of error that they're saying we want at most. So that was the 3.5 percentage points. But we can't enter it as 3.5. We need to convert that percentage to a decimal by removing the percentage symbol and moving the decimal 2 spots to the left. So our E is going to be 0.035. The one piece that remains after that is Z star, and that's based on the 95% confidence interval that they asked us to do. So we'll draw a quick bell-shaped curve. We'll throw that 95% in the middle. In decimal form is 0.95. That leaves 0.05 remaining. Cut that in half, and that would be 0.025 on each side. Always make sure, after you've done your picture, that the left number, the middle number, and the right number, when added together, give you 1. That makes sure you didn't put your decimal in the wrong spot, that you remembered to cut the leftovers in half. So always check that, and then use that picture to help us find Z star. But it does turn out it's a little easier the way the calculator works to find the one on the left first. So we'll look for that negative Z by using inverse normal. With inverse normal, you need to know the area to the left of your value. That's this number here, so 0.025. And then we go to the calculator and see what we get for that. So let's switch over. So we want to go into our distribution menu, choose inverse normal, put the area to the left, and we get negative 1.9599639845. We want to round that to 3 decimal places, which would be negative 1.959, except the digit following our 9 is another 9, so we need to round up. That can be a little tricky when you're rounding up a 9, so instead think of it as rounding up a 59. So if you round up that 59, you get a 60. So negative 1.960 is what we're going to go with. And then Z star would be the positive version of that, so positive 1.960. And then we have all the pieces we need. So this was all scratch work for us. So now let's go back and start plugging in. So for our guess at P, we're going to use 0.1844 times 1 minus that, which would be 0.8156. And then we're going to multiply that times our Z star, 1.960, divided by the margin of error they asked for in decimal form. So 0.035, and then square that. And then we'll go to the calculator and see what we get. So let's switch over to the calculator. And we want to start off with our guess at P, 0.1844 times 1 minus that, 0.8156, times, very important, open the parenthesis, put your Z star, don't close the parentheses yet. Do the division first by the margin of error they want, then close the parenthesis, then square to make sure we're squaring that whole fraction, not just the denominator. So rounding that, we get about 471.64. So approximately 471.64 is what we come up with, but we can't use a decimal for sample size, so we need to either round up or down. And when we're calculating sample size for the purpose of getting a specified margin of error for a confidence interval, we always round up. In this case, rounding up is natural with the 0.6, but even if it wasn't, we would round up anyway. So we're going to use n equals 472, so that 472 is what we put into active learning. So some key things: make sure you convert your margin of error to a decimal form before you plug it into the formula. Make sure that your three areas add up to 1 so that you're not making any decimal place mistakes. Make sure you remember to get those parentheses and the square. People forget to square completely sometimes, so be aware of that. And I rounded up here, it was natural, but we're going to do that always. So even if this was 471.46, we'd still round up. That's just what you always do when calculating a sample size required to obtain a specific margin of error, with the logic being you never want your sample size to be too small, so better to round up than down. I hope somewhere in there you've found the mistake that was giving you trouble when you tried the quiz. Good luck to you as you head back.